Today, we're going to take a look at the Creality Sonic Pad, which is a control pad to convert your Marlin printer to Clipper and control multiple printers from one screen. Without further ado, let's unbox this guy. So the packaging is nice. I mean, that's always a nice touch. We've got some little stickers, it looks like. And the 7-inch touchscreen. There we go. And so we'll go over all the different ports and features of this in a minute, but that's kind of the main unit. Little kickstands on it. Then in here we have a micro USB to USB. We've got this other cable with a proprietary connection on here that goes into the pad. And then this is a gyro. So it's got X, Y, and Z direction indicators. You attach this to the hot end and we'll use that to tune what's called input shaper. Input shaper in Clipper is going to allow us to reduce the ringing at high speeds. So as you come around a corner and change direction quickly, sometimes you'll end up with a little bit of a wobble and you'll see it in the side of the print, especially like if you're printing a tall print, you'll see it in that side. We can significantly limit that by kind of tuning out the resonant frequencies of the particular machine that we're printing with. So that's what we use this for anyway. We have the power supply. It is 12 volts, comes with its own power supply, so you don't have to worry about that. We've got a USB drive and a couple adapters here. So it's like USB-C to micro USB adapter and a mini USB to micro USB adapter. So I guess that's going to allow us to use this micro USB cable on any printer regardless of what connector it has on the other end basically, aside from USB-B, the bigger printer cable or connector. And we have universal adapters for the electrical connections. You know, if you were in Europe or something, yours might look like this. Ours in North America looks like this. And so just install that like that. So if you've read anything about Clipper, you'd probably hear people referring to it running on a Raspberry Pi. It can run on any kind of compute module. In this case, Creality have designed their own SoC, so it's not running on a Pi compute module, but for all intents and purposes, very similar outcome. And why would we use Clipper instead of Marlin? Well, we know even though we have 32-bit boards now and they're much faster than they have been in the past, a Raspberry Pi or a module like this is running in the gigahertz range instead of maybe 100 megahertz range. So that's about 10 times more compute than what we would have on our onboard. What that allows us to do is do a much better job predicting future moves in advance and compensating for them. So I did mention input shaper and limiting the ringing, but also how we do pressure advance, which in Marlin is called linear advance. So limiting the amount of ooze that happens, let's say when we stop and change directions at a corner, there's still filament coming out even though we're not pushing any through. And so you can end up with bulgy corners at times, and pressure advance or linear advance really helps with that. So it's able to do much better kind of predictive analysis, if you want to call it that, to tune that in a lot more sharply. So it's just got more horsepower in general. So much so that we can run 3 or 4 printers off of this. So in this particular model, we have 4 USBs, but it appears like one of them is specifically labeled cam. So you can set up a webcam and do time lapses and stuff like that from here. So if you're using that, then likely we can only have 3, but we'll get to that later through the manual. In Clipper, you're given a web interface typically to interact with. So you can choose to do anything you want on this screen to control your multiple printers, or you can connect to this via Wi-Fi on your phone or on your laptop or whatever, and have a full web interface in order to control your printers. So it gives you flexibility, right? If you happen to be in the room with your little print farm, then by all means it might be convenient to use this. So what that means is all the compute is happening in Clipper, right? So that's your firmware. It's also the firmware that runs on the printer. And so the printer ends up being more or less just a slave. So Clipper on here will say, hey, move to this location, move this fast, you know, extrude this much material, stop now. All those commands are just acknowledged and responded to by the printer. The printer doesn't do any smarts or compute on its own, it just responds to the commands given by Clipper. So what that means is we have software that runs on here, but we also have the corresponding firmware that's running on here. So we're going to need to flash our firmware on our device. Now, This out of the box supports a wide variety of Creality printers out of the gate. And with a little bit of configuration, you can have it support many other printers. I myself at home, I have Clipper running a Voron, which is a completely different machine altogether. As long as you go through the exercise of setting up the config file for your particular printer, you could do the same. Now, this just makes it very easy to onboard using this for any of their supported printers because there's configuration ready for you right out of the box. So as I mentioned, we have 4 USBs, one's listed CAM. We also have a hardwire Ethernet jack, so you don't have to use Wi-Fi. It does have built-in Wi-Fi as well. We've got the port for the 12-volt power input, obviously. We have our sensor, so that was our gyroscope here for input shaper tuning. And then we have the 2 USBs on that side and a power button and some indicator lights on this side. The screen itself is 7 inches. It is a capacitive touchscreen, so like your standard smartphone touchscreen would be, and it is 1024 by 600 resolution, so 1024 by 600, and yeah, it is 7.0 inches. That wireless that I mentioned, the wireless capability it has, it is B, G, and N. So you're not going to have wireless AC, for example. So if you have a router that's broadcasting, say on the 5 gigahertz, that's probably wireless AC or higher. So you're going to want to broadcast wireless N, which could run on 5 gigahertz or 2.4, but just make sure that you're using BG or N wireless, or that you have the capability of spinning up another SSID, which is a wireless name, and broadcasting BG or N to that particular SSID to get this guy connected. I also mentioned that there's 2 gigabytes of onboard RAM, so random access memory, just like your computer. So this has got 2 gigs, and it's got 8 gigs of internal storage, so ROM. So that's where our software and stuff would be installed into. Any videos that we took, if it was taking time lapse and saving them here, then that would be taking up your ROM space. So that would be subtracting from your 8 gigs. So being that this is literally my first time ever looking at this machine, I've read through the instructions briefly, and we're just going to go through the instructions step by step together, so you'll be able to get a feel for what the process is like, and you might be able to refer back to this as a visual indicator of what the instructions are telling you to do if you're doing this in the future. So first steps first, we're going to have to connect power, obviously. Too many cables, power. And then we're going to use that USB cable that we had with those different adapters and find the adapter, or maybe it's just the micro USB itself, that corresponds to the connector on your printer. This printer has it in the front, which is somewhat inconvenient from a cable management perspective. Would have been nice if it was in the side, but that's what we have to work with. And it is a USB-C, so that's the bi-directional modern USB. So we'll add that adapter on there, plug that in the front, like that, and then we will plug that into one of these side ports. And then we'll just connect this into the back. Okay, so we're plugged in. Let's turn it on with the one button on the side. So it is, it's not like just an instant press button. It kind of like clicks in and stays clicked in. And then we saw a blue and a green indicator on the side here. Blue is blinking and green is solid. So once it's done booting up, we're basically just going to follow the on-screen prompts to set up the device initially. There'll be some options like what our language is, the region that we're in. We'll punch in some network settings to get it connected to the Wi-Fi. And I know that for the firmware on here, the software on here, that there's an OTA update, so you can do it over the air instead of having to download it on a USB stick and plugging it in, though that's also an option as well. All right, so we're going to choose English next. There's a little speaker in the back as well. I agree. Of course, I've read all of that. Next step. Sure. Next step. Please select my region. So we're in North America. There we go, America, Toronto. So that's essentially setting your time zone, right? Next. So now it's already scanned for the SSIDs or the Wi-Fi networks that are in our area. I've got one that I've called Printer Wi-Fi, so that's what I'm going to connect to. And then we'll just type in the password. Great, connected successfully. So we will now go to next step. And please name your Creality Sonic screen. So we're just going to leave it as Creality Sonic Pad. As I mentioned earlier, Creality provides a bunch of configurations for a lot of the Creality machines. And here we have the Creality S1, and here we have the Ender 3 S1. And so we see Ender 3 S1 listed here. Now it's actually listed twice. And if you look at the subtext, it seems like there is a different chip that's on the board. And so you might not know which one you have. If you choose the wrong one and go through the steps and try to flash the firmware, it just won't take. So if it doesn't take, then try the other one, essentially. In this case, I happen to know that this one we have here is the 103 chip, STM32F103. So I'm going to select that one and hit next. Now it wants me to put in the SD card. This printer happens to use a full-size SD card in the front. And to do so, I need an adapter that the screen doesn't come with, but the printer did, right? So I've got the USB adapter, put in my full-size SD card. Depending on your printer, it might be a micro SD, but regardless, you need to get it in a USB, insert it in the spot that they show, and hit flash the firmware. Give it a second to properly detect. There we go. Great, now it says that the firmware is now written to the SD card, so now the next step is we're gonna put it in the printer, but for now, we'll just remove it as it says, hit next step. Okay, so put it in here, make sure the printer is off, and now we're gonna turn the printer on and hit next step. Make sure the printer is connected as shown, it is. This may take a little bit because it is flashing the firmware. There we go. Okay, so now on the screen on the Ender, all we have is the Creality logo. We don't have any of the normal controls anymore. As I mentioned, the printer is largely just a slave to the commands of this guy. Sometimes you will have printers that will have some degree of controls still here, like homing and moving the axes and whatnot. In this case, we don't. But ultimately, this looks different. We now know the firmware has been flashed, and this is now detected Clippy on this side, which is the Clipper firmware on the printer. So now we're gonna do the self-test. It says, make sure that the Creality Sonic pad is properly connected to the printer. It is. Please ensure that the printer's hotbed surface is clean. Relatively, it's got some glue stick on there, but that's fine. By clean, I think they mostly just mean that there's no prints on it, but regardless, it's ready for printing. It's just got glue residue. And then the self-test process will take about 30 minutes. Okay, start self-test. All right, the hot end is starting up. Please check if the fan is spinning properly. Yes, it is. And so the fan that they're referring to there is the cooling fan for the heatsink, for the cold side of the hot end, not the part cooling fan. So yes, it is on, that's good. Next step. Check that it's spinning properly, it is. If it does not start properly, please check the manual and troubleshoot, but we are fine. Okay, now I just heard the cooling fan, so that's the part cooling fan here. That's running, so yeah, that's good. And no need to troubleshoot, we're fine. Okay, please confirm that all the hotbed screws have been tightened to the maximum. Click next after confirming the preparation. All right. You gotta remember that any Zed Offset or bed leveling that we've done before is essentially moot because we've just wiped the firmware. So we're starting from square one and we're just going to follow the instructions verbatim and not ask any questions. All right, so I've tightened the screws as much as they can go all the way around and then hit next. Okay, so it says it's homing. It's doing Z safe homing, so moving to the center to probe the bed. Okay, so it's now probed the bed twice in the middle and it's got the Zed Offset at 4.96 millimeters. So if you recall from maybe when you set up your machine originally, assuming you had a BL Touch, the Zed Offset is the difference between where the probe hits the bed and where the nozzle actually is. So the nozzle is obviously higher than the probe, otherwise the nozzle is hitting the bed. So that difference there, in this case, it thinks is about 4.96 millimeters as a starting point. And so now we're gonna further refine that. Select the travel distance in millimeters and we can move it up and down, yeah. So we'll get our standard piece of printer paper. I am making some assumptions here because it doesn't actually tell me what to do, but it gives me the up and down, the increments to move in, and it's moved the nozzle to the middle. So I think it wants me to verify if moving Z down to 0 is actually at 0. So now we're at 0.96. We'll move in smaller increments, say 0.5. Okay. Still not even close. And we'll just keep, oh yeah, we got lots. Let's go down further, a little bit further. Now, because we're not doing this at temperature, we can see up here that the hot end is not preheated. You need to make sure that your nozzle is clean for sure. Otherwise, any plastic that's built up on the tip of the nozzle is going to throw off, what we're doing here. So now it says minus 2.84. So that means that the nozzle is 2.84 millimeters above where the probe is. Okay. So now we'll hit next step. Again, this is cold, but that gets us close. Next step. So now it's homing again. So it just homed, and it's telling me, to go to the individual corners, press 1, 2, 3, 4, and when it gets there, slide your piece of paper underneath and just adjust the screw, loosening, because they're all the way tight, right? Until you have kind of the normal amount of paper drag between the nozzle and the bed. Now the first corner, you're probably gonna have to loosen it quite a bit because the others are all tight. You'll go around 1, 2, 3, 4. And once you've done each one, do it a second time and you'll probably find that corners are too tight. So you might have to tighten a little bit to provide some more space between the nozzle and the bed. And then maybe just check a third time just to be safe, okay? So 1, 2, 3, 4, 3 times around, and then we'll hit next. Now I will say that I would normally be instructing you to do this with things at temperature, both the bed and the nozzle. At the very least, the nozzle, so that if there was any plastic buildup, that it's molten and not really influencing our results much. But that's why it does say to make sure that they are completely clean. But it just doesn't sit well with me that we're not at temperature. But we'll follow the instructions. Next step. Okay, so auto level. Please be sure the hot end and nozzle are clean before calibration. What kind of a temperature setup? What are we going to do here? Set the hotbed temperature. Okay, so we'll set the hotbed to, can I type in a number? I can, okay. Set that to 60. Okay, the hotbed temperature is being adjusted. Please level it later. Okay. Oh, I guess that's gonna stay on until we get there. So at the top here, we do see the nozzle temperature. So it's 24 of 24 degrees, which basically means there's no set temperature right now, it's just ambient. Here, it's currently, the bed is at 31 degrees out of 60 degrees, so it's got a set temp. So we'll have to wait until that hits 60, and then we'll do the same thing with the nozzle, I think. All right, so our bed is finally up to 60 degrees. So under temperature setup, we can only set the bed temperature. We can't set the nozzle temperature, so I feel, half better about that anyway. And so it says, make sure the hot end and nozzle are clean before calibration. So I suspect that it's just gonna probe a grid, looks like, what, 5 by 5? Yeah, so it'll probe 25 points all across the bed and build that normal topographical kind of map or mesh to map out any of the peaks and valleys and be able to compensate, do auto bed leveling for us. Okay, so that's done. And now we can see the graphical representation of the bed topology, as I mentioned. And while it looks super non-flat on that perspective, you really need to pay attention to the scale here, right? So the white, pure white would be 0, so flat. Pure yellow here, this like middle yellow, it's 0. And then minus 0.1 is almost pure white, minus 0.2 would be pure white. So pure white to yellow means that there's a 0.2 millimeter difference between white and yellow. And that's one layer height. That is quite a bit, but that difference, it's kind of hard to tell if is that white, is it yellow, various shades of yellow. We're essentially within 0.1, maybe 0.2 at most variance across the bed. Ultimately, it'll compensate for it. It gives us the actual measurement at each of these points. And so we can see over here we have minus 0.23 and over here we have minus 0.02. So there would be a 0.21 delta from that corner to that corner. So that could be, you know, because I was doing the paper leveling for the corners, maybe I have this one too tightened, therefore too much space between the nozzle and the bed, or too little space, vice versa. So I may want to do my corner leveling again and pay extra close attention to how much drag I have on the nozzle. But ultimately, that's what's mapped out. We'll leave that and hit next. All right, now we're ready to start our experience. So we're just going to be at the home page, and here's the home page. So we've got a graph of our temperature over time for both the hot end and the heated bed, and shows their current temperatures as well with their target. We can move the axes, you know, X, Y, Z, home, etc. Preheat. Control is going to have options like extrusion parameters here. This would be, you have to heat up the nozzle, but you can choose how many millimeters to extrude, and then what speed to extrude it at. You can extrude or retract, and obviously you need to set your temperature first. Emergency stop button in case something goes horribly wrong. Fan, we can probably control the cooling fan, yep. And the hot end fan, you can see that it's off and it's got an X through it. You would never want to manually control that fan. It's typically temperature controlled. So when the hot end is above 50 degrees Celsius or so, it will kick in. In other printers, it's whenever the hot end is energized, then the fan is going at all times, regardless of the temperature. But either way, you're not gonna manually control that one. Temperature, I think we're just gonna be able to preheat hot end and bed. And let's just, motor's off. So if I needed to manually move these things and the motors were energized, it would be very stiff. And so clicking motors off would allow you to do this manually. And so then if we go print, we have various places that we can pull print files from. So they can be loaded onto the pad itself. We would do that through the web interface more than likely. I could have a USB stick that I plug in here, and then I would select USB stick, but unfortunately there is no USB stick right now. Creality Cloud, so we can definitely have this hooked up to Creality Cloud, and any of our sliced files that are up there we can pull down dynamically to here. And then it'll have a running history of the print jobs. So under configure, we can go and do our manual leveling, which was what we did at the corners. We can do the auto leveling sequence, which we just saw there a moment ago. The probe calibration, so this was our Zed Offset that we did early on in the setup sequence. If we needed to, you know, if we changed a nozzle or something, we may have adjusted the height of the nozzle overall, depending on how the length of the nozzle and how tight we tightened it. All those little variances matter. So whenever you do any kind of mechanical work like that on your hot end, you would want to redo the probe calibration. Network settings, so here, if we go to wireless network, we should see our IP. And so that is the IP. We're using DHCP here, so it's just automatically assigned. But that's the IP that I would connect to in my web browser on my laptop, which we're going to do in just a couple minutes to get to here. And this is also the screen that we would use to connect it to a new Wi-Fi name if we needed to change that. Now, wired network, we're not hardwired, but that would show you the IP address and similar information for the network you're plugged into. Local information, so I suspect it's going to show us serial numbers and firmware versions. It's also showing us how much of our memory we've used up. So as I mentioned, there's 8 gigs of internal storage. Right now we're using 41.9 megs, so not much out of the 8,000 or so megabytes we have. So the pad firmware, that's the firmware on here, and the release date of that firmware. So that's October 31st, 2022, so relatively current. The printer that we've got configured here, and a little picture of it, some details about the print size, and then the MAC addresses of the wired and wireless Ethernet cards, or network cards. Save configuration, what's that gonna do? Well, that's fine. Every time we make a change to like the Zed Offset or something, it's saving the configuration in the background. I'm not sure. Maybe there's some settings on there that you would change and it's not gonna auto-save. I'm not sure. But if I go back to configure here, so camera, as I mentioned on the back, there is the 1 port labeled camera. It does mention that the webcam is sold separately. What's not clear is like the CR10S Pro, I think it was called, that came with the webcam. It was only their specific webcam that would work with it. I tried the popular Logitech C920 and it didn't even recognize the camera. So I'm curious if this has a broader compatibility with standard webcams that people would be using, like something like the Logitech C920, which I believe you're using motion JPEG by default for the video stream. But anyway, that's something for us to determine in the near future. And then other settings. Okay, so we have things like the brightness, break screen. I think that's like screensaver, maybe 5 minutes. We've got our language, the region, the time, you know, all those things that we set up early on. And then themes. So this is just going to be graphical theme. Looks like there's only one right now for the UI here. And then pause timeout setting 10 minutes. I don't know what that means, but we'll have to read the manual more. Keytones, so that's making a noise every time I hit a button, like you hear. System upgrade, so current version, this shows our current version, and this is the latest version. So we don't have an upgrade, but that would be the OTA upgrade I was talking about, where it would download the newest version over the internet and then flash this. One touch changeover, set time. It's under advanced options. Console. So if we wanted to send raw G-code commands, we would probably do it through something called the console. If I turn this on, we can also do PID calibration. So this is hot end heating and cooling cycling tuning, right? To really dial that in. So instead of saying I want 200 degrees Celsius and it going 202, 198, 202, 199, you know, and kind of fluttering up and down, you want that to be as smooth exactly at 200 or whatever your required temperature is as possible. That's where PID tuning comes in. So it's nice that there's options right there for that. You can also do PID tuning for your bed. And so you wouldn't want the bed to fluctuate much because it will actually kind of almost cause a breathing effect, if you will. And that can appear like Zed banding as you go up because the bed is heating and then cooling and then heating and cooling. So you want that to remain as steady as possible too, right? Consistency is very important. So let's go back and see if we can find the console menu. I wonder if it puts it on here. Maybe not. So the console menu is back under control. And now we've got a new menu option here called console. And a bunch of text on screen here. I think it's giving us some of the feedback from Clipper. Yep. And if we wanted to enter manual codes here, so if I did like a G28, let's see. Should be home all axes, right? And it's interesting to note that it didn't care about capitalization. I know some console interfaces want like capital G28. But there we go. So if you ever have a specific command that you need to issue, you can do it through there. What I'm not able to demonstrate, of course, is what it looks like with multiple printers hooked up. So the manual does say that the first printer has to be hooked up to this interface, and we saw that through the on-screen guide. It does say that there can be up to 4 printers. So we've got 1, 2, and 3, 4 ports. But one of those ports on the back is labeled camera. It does seem like that can support a 4th printer, but of course, if you've got that 4th printer, you can't also use a camera for time lapse, right? There's also some instructions in here about setting up your particular slicer. They cover Cura, Super Slicer, and Prusa Slicer, for examples. And one of those setup options is to generate thumbnail previews. So the little preview image of what you're slicing, that will be shown on the screen when you select the file through the file list. So that'll be helpful because what was the file called bracket 1? You know, what did that look like? Oh, that's the shelf bracket, not the, you know, phone bracket that I had, right? Obviously, naming your file something better than bracket 1 is good practice as well, but having the picture is just a nice reinforcement that I've chosen the right file. So I suspect that you would actually choose the printer that you're controlling on like the home screen. And since we only have one, it just jumps us right into the one default printer. So I think that's a fair assumption. Don't quote me on that. But let's take a look at what the web interface looks like if I didn't want to use the tablet and I wanted to access it from my laptop, maybe from another location even. Okay, so loading up your favorite web browser, and you have to obviously be on the same network as the pad was. And if you remember from the network information screen, we had an IP address. So 192.168.125.199. In our case, yours may be vastly different. So you may have seen there a moment ago, it said Moonraker. There are multiple different UIs that people can use for controlling Clipper. I happen to use Mainsail. Moonraker is another one. I believe you can also use Octoprint, which many people are familiar with from many years ago. They're using Moonraker, obviously Creality branded in some sense, probably customized a little bit. But we see the same kind of information as we did on the pad. So we've got our console information. So we saw this in the console on the pad. This is where we're going to do things like G28. And there the printer goes, homing again. And you can see the previous G28 we issued like 11 minutes ago in real time, not in video time, but I did lowercase G28 from the tab, and then just now I did G28 from the console here. File list, so this is listing the files. I would assume this is from the onboard storage. Something I didn't touch on the screen is there's the concept of macros. So you can think of these as like sequence of G codes that you can just click one button and issue them. So in this case, G29 is ABL, mesh bed leveling. So that would kick that off. And you can label these, you could call this bed leveling, and in the background it's going to issue the G29. Time-lapse take frame, test stream delay. I'm not sure what these things do. Is this a resume and pause velocity? I don't know. Pause and resume with a velocity option. Interesting. But anyway, these are macros. And then here we've got pressure advance. So this is what I was speaking about earlier, making sure that you kind of control bulging corners and keep them nice and sharp, even at speed. Flow, so your standard flow control. If we scroll down, we've got part fan, so you can control this independently even while the print's on, or even while the print's off. So there we go. And so I just dragged the part fan up to 82%, but you can see the command that was actually issued behind the scenes, M106 S210. So if you remember, M106 is set the part cooling fan, S is set it to 210, and this is out of a maximum of 255. So 82% of 255 is probably 210, right? And if I crank this to 100, that should be 255, right? Makes sense? And then let's just turn this off. Oh, that's the hot end cooling fan, not part cooling fan. So let's turn this off. There we go. So printer limits. It's set the maximum speed to 300 millimeters a second. Now, if you're comparing this to the speeds that you would normally print on this printer at, you're never going to be hitting 300. I also still think that that's extremely optimistic on a Cartesian, while retaining quality, that is. But you can play with some of these settings, tune them up and down as you start going through and tuning in, pressure advance, and you're probably going to want to use input shaper as well. There are instructions in the manual about using input shaper, but I think we're going to leave that either for a separate video or for you to experiment with on your own. And then you can actually relaunch a job that you previously printed from this menu here, and we've got an emergency stop here. You can set up different users. You can restart services, like the Clipper service, you can restart it. And usually you can also do upgrades from here. So if we go maybe settings. So we've got our time-lapse settings and our cameras, macros, themes, system. So performance stats, here we go. So you can restart Clipper. You can restart the firmware. So restarting the MCU is now the printer's board inside the printer. That's the MCU. It's got some details here about their processor, so it looks like they're using an ARM processor, 1.9 gigs, T800, that's what they call their chip, the Creality's processor chip. They're using Linux, and then some other details here. But where is configuration? So Printer.cfg, this is, how I said out of the box, it has configurations for a bunch of Creality printers. This is the configuration. You'll be responsible for creating your own, which is specific to the printer, the board, and the pinouts that you're trying to configure if it's not one of the ones that are supported out of the box. Tune, there's our bed mesh that we saw. A little easier to see actually the discrepancies. The coloring here is a little bit more obvious. So we could, reprobe, we can recalibrate. home all. We've got a filament runout sensor. Right now it's triggered because we don't have filament in there, so that makes sense. Time lapse, we don't have any saved time lapses. File list. So some of these things, you see on here as little applets, but looking at them in full view, console gives you the full page console instead of a tiny little window to type in. And then we can move the individual axes and home all of them. And it currently tells us our current positioning as well. And you can extrude and retract filament here at different increments. Different increments for the Zed Offset. So, it's exactly the same things we saw on the tablet, except you're obviously able to fit a lot more on the screen at once. It might also be a good idea to set a password for the user so that to get to this page, you at least have to enter a password instead of just ending up here, especially if you have, siblings or other people on your network that might tinker with your printer. But right now it's unauthenticated. We got right to the page just by typing the IP. So considering it's a very easy way to flip your printers over to Clipper, and you're getting a 7-inch touchscreen, which alone to get a 7-inch touchscreen for a Raspberry Pi, if you're going to do this on your own, costs you an arm and a leg. I think this is a fantastic value. It's relatively easy to set up, with the on-screen instructions and the detailed manual, and it gives you a whole new life to potentially an older printer. Right? Not only can you increase your speeds while retaining quality, you've got a bunch of new features to play with as if you needed more to learn. So you've got your input shaper for the resonance control. You have your new pressure control calibration. You have a new web UI that you can use where this printer previously didn't have any web connectivity. And you've got a UI on the tablet here. And you can control multiple machines. So instead of having to have multiple SD cards and keep copies of all your prints, especially if you're printing multiples of the same item, at one point I was managing 26 printers, and I wasn't managing them as individuals, I was managing them through something similar like this, because I can just have my jobs and say, send it to printer 1, send that to printer 2, send that to printer 3, all centrally from either my tablet, my phone, my laptop, etc. This is a fantastic way to be able to do that without having to learn all the nuts and bolts about setting up these pieces of software individually and piecing together your own hardware contraption. Hopefully you found that useful. There's lots to learn. Have fun with that, and hopefully you like and subscribe and check us out for more videos in the future. Thanks for watching.